All right, class. Let's talk about section 5.4, right triangle trigonometry. Most of you, this is what your first experience was with this, trigonometric functions. You have started with a right triangle and try and solve it. What does it mean to solve a triangle? Find missing angles and sides. So I might need to find this side or that side or this angle. So you started in a right triangle. Okay, how does it translate? I already talked about it in 5.2 really, but let's talk about it again. So we started with an angle in standard position, terminal side somewhere, right? And I said, okay, the definitions were that if you have this angle in standard position, the sine value of it is y over r, right? The cosine value of it is x over r, and then from there we build on tangent, cotangent, and so on. So we can take this triangle really out of there and just talk about simply a right triangle. So what if our angle was going to stop in the first quadrant? And here is our angle theta. And then being a right triangle, we can call it whatever we want it to be. We're going to label it sides A, B, C. In a right triangle, we usually reserve C for the right angle. And that's going to be customary what's going to happen. And then what's the sine value of this angle theta? Well, it's y over r. For us, for this side, it becomes AC over AB, which in this case is, we call it the opposite over the hypotenuse. Do you remember that? So it's the opposite leg divided by the hypotenuse. Cosine of angle x, of angle theta, is the x over r. So the cosine value is BC over AB, and what that translates into is the adjacent side over the hypotenuse. So it's the adjacent leg over the hypotenuse. And let me write tangent just the same, since now we know about it. Tangent is y over x, so tangent is y over x. In other words, is the opposite leg over the adjacent leg. And again, these are trigonometric identities or formulas that we use just for the acute angles. It does not refer to the 90-degree angle. I know to find sine of 90 is 1, cosine of 90 is 0, tangent of 90 is undefined. It is for the two acute angles in a right triangle. So sure enough, I'm sure you remember the mnemonic SOHCAHTOA that tells you what? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. So what we want to do is just use these identities, these new formulas, to solve these right triangles. So I drew them out for you already. What does it mean to solve a triangle? It means to find the missing sides and angles. Now, when I'm missing the 90-degree angle, we know it's a right triangle, that's for sure. So then, first, the easiest one to find is the other angle, if you should be given one. So A is what? 30 degrees, yes, because they have to add up to 90. That's easily found. Good. The other thing is, in a right triangle, we usually, or any triangle, we label the vertices of the triangle ABC. Let's say C should be the right angle. But then we also label the opposite sides according to the angle. So if this is angle A, we'll label this side A. This is angle B, we'll label this side B. And this is angle C, we will label side C. So we know side B, but we need A and C. So sure enough, I could maybe use sine of angle B is the opposite, right, which is 10, which is the B, over the hypotenuse, which is this value C. I could have grabbed cosine of B first, or sine of A. This is an exact value, so it's not a big deal. I could have used either trigonometric formula from there or connection, and I would get the same answer. So out of this, solving for C, cross multiply, C is going to be 10 divided by sine of angle B was 60 degrees. And by the way, we know the exact value of this is square root of 3 over 2. But the point of this is actually to just come up with a answer. We're fine. 10 over, let me write it here. C is 10 over sine of 60 squared of 3 over 2. So that's a 20 over the square root of 3. So it's 20 square root of 3 over 3. That's the exact value. It's fine if you give me a decimal for this one. It's not a big deal. So there's that. What else do I need to find? I need to find side A. How could I find side A? Again, I can use tangent, I can use cotangent, I can use the sine value. I mean, now that I have this C, I could, again, either one of them, try them all, and you'll see I'll come up with the same answer. So what I'm going to do though, I am going to use the angle given, which was B, and the opposite side B to it, and find A. So what links this angle? The opposite side and then the adjacent side. Well, that'll be tangent. So I'll go to tangent of angle B, which is opposite, over adjacent, which is A. So from here, side A will be 10 divided by tangent of B was 60 degrees. And if you remember from your table, tangent of 60 degrees is square root of 3. So that's a 10 square root of 3 over 3. So these are the exact values. Again, you could have put them in the calculator. But since these were some of our nice angles, I decided to review those exact values. Okay, let's see about this triangle here. Same thing. I am given angle B. To find angle A, I'm going to simply minus this out of 90. So angle A should be definitely 27 degrees, I believe. Right, adds up to 90. Cool. And then I have side A, okay. And that means I need side B, and I need side C. So this leg and this hypotenuse. Great. So let's say I'm going to use tangent of angle B, which was given. So tangent of angle B is the opposite, which is side B, over the adjacent side, which is 30. So from here, I can solve for B. So B is equal to 30 times, this time I don't have an exact value. I have no idea what tangent of 63 degrees exactly is. Well, close to that, but what is it? So put this in your calculator finally, and you're gonna come up with, well, about 58.88 apparently. So 2 decimal places is fine, okay? And then how do I find side C? I'm going to, again, you could use angle A. It's an exact value. It's really not a big deal. I would not use anything that involves side B because we already got this by approximation. But I'm going to challenge myself and just use angle B and this adjacent side to find C. So hypotenuse, adjacent side, and this angle, that's a cosine. So cosine of angle B is the adjacent side to it, which is 30, divided by the hypotenuse, which is C. So how do I get C out of this? Again, C, cross multiply, divide by cosine. C is going to be 30 divided by cosine of 63 degrees. Put that in your calculator. And I don't know what it is. I didn't even write it in my notes, but you can figure it out from the calculator. Okay, so there's that. That's how you solve triangles. To start, there's so many connections between all these angles. You can figure them all out, no problem. So as I said, you could have used sine of 27 degrees is 30 over C. You could have gotten C from there. You could have used tangent of, not tangent because that's the legs, but yeah, sine or cosine will get you. Oh, the other thing you could do, you have the side 30, you have B is 58.88, you could use Pythagoras theorem to find the third side. As I said, I don't recommend you using values that you got by approximation. But again, we're just approximating or rounding to 2 decimal places, so that's not a big deal. You'll get close enough to the answer. Okay, so the next problems that I said I would do, where did I put that paper now, would be, oh, there it is. We have problems 48, 50, and 52 from our book. I'm going to start with 52 because that's the easiest one. And problem 52 in our book on this section says, a 33-foot ladder leans against the building. So here's a building. And here's a 33-foot ladder. Well, it's straight, but anyhow. So that's the ladder, and it's 33 feet. It leans against the building so that the angle between the ground and the ladder, that's the ground and that's the ladder, this one's 80 degrees, yes? How high does the ladder reach up the side of the building? So the building might be taller, and the ladder only reaches up to here, and that's perfect because that's exactly what we could find out of this right triangle. So I want this side here, I'm gonna call it X. Okay, so no big deal. What will connect this angle, this opposite side to it, and the hypotenuse of this right triangle? Sure enough, that's a sine. So sine of 80 degrees is the opposite, which is X. I called it an X. Over the hypotenuse, which is 33. So same thing, cross multiply, right? I mean, that's a 1. So 33 times sine of 80 is equal to X times 1. So X is just 33 times sine of 80 degrees. And I don't know if I have an answer for this, but let me see. Do I have it? It's about 32.5 feet. All right, no problem. So that's how easy it is. So the main, most important part of these word problems is the picture, right? So read the picture, think about what it is and how is it supposed to look like, and then you got the problem done. So once I have the triangle and it's easy to solve, the picture is really the main part of it. It's kind of like in a word problem, can you set up the equation, then the rest is easy, solving it and so on and so on. But can you set up the equation? That's the thing. Can you draw the picture, right, to the story? Oh, there's problem 48. It says, a 200-foot tall monument is located in the distance. So I'm going to draw for you a 200-foot tall monument. There it is. From a window in a building, a person, so there's the monument, and somewhere in the distance there's a building. Okay. There's a guy in the window of this building. So it doesn't mean it's, here's the window, and here's the guy behind the window. Whoops. I'll give him a neck, legs. There you go, there's the guy. Good. So from a window in the building, a person determines that the angle of elevation to the top of the monument is 15 degrees. Now we definitely need to know what is an angle of elevation. An angle of elevation, or an angle of depression, as the next part will come up to say, is the angle made from the horizontal. Elevation means you're looking up. So from the horizontal, in other words, what? From the line of sight. This is how tall the person is. That's where he's at in the building. And then he's looking up. Yes, so the angle of elevation is from the eyesight up. So from his eyesight, from the window to the top of the building, he knows, because he's got laser vision, that's 15 degrees. Okay, and the angle of depression, so from the horizontal, right, from the eyesight, looking down, that's an angle of depression because you're looking down to the bottom of the building, is 2 degrees. Okay. So it says, how far is the person from the monument? So how far is the person from the monument? In other words, really, how far is the building away from this monument? All right, well, I don't know. Let's see. Well, the thing is, this is the ground. This is the horizontal line. So these should be right angles, yes? So horizontal up here, horizontal down here. These are parallel. Those angles here, the building is perpendicular to the ground. It's going to be perpendicular to this eyesight line. Okay, so what could I figure out? Okay, well, this is what I know. I know that this whole thing is 200, yes? But I'm not sure how much is it to here and how much is it to here. Well, let's see. I'm going to use 2 parts. I'm going to call this side up to here A, and from here all the way to the bottom B. By the way, these problems will be easily solved by the time we get to chapter 8, and we'll talk about the law of sines and the law of cosines. That's going to make computation much, much easier. For now, what we need to have is a right triangle. So let's see if we can figure out the side A from here. Well, what would connect, and I want the, right? I don't know the 200, yes? I have a right triangle. I know this angle's 15, and I know this side from here to here is some x, and this side from here to here, I called it an A, okay? So, what would connect the 15-degree angle, the x, and the A? These are both legs, so it's definitely a tangent, yes? So tangent of 15 degrees is the opposite side, which is A, over the adjacent side, which is x. So I'm going to solve this one for A. So A is equal to x times tangent of 15 degrees. Great. The same way, can we determine a connection between B, x, and this 2-degree angle? Sure enough, same thing. Tangent of 2 degrees is the opposite, which is B, over the adjacent leg, which is x. So same thing, I'm going to solve this for B, and I'm going to get that B is x times tangent of 2 degrees. And as I said, I really don't care what A and B are, but do you know anything about A and B? Definitely, I know that A plus B makes up the 200-foot building, so I know that if I add these two, and substitute A with x times tangent of 15 degrees plus x times tangent of 2 degrees, I'm going to get a full 200, yes? So as you see, this equation here is only missing on a variable, right? X is your variable, the only one. Can you find tangent of 15? Sure, put it in your calculator, right? Be sure you're in degree mode, by the way. That's also very important. When you find these angles, be sure, says 15 degrees, that means you should be in degree mode. What if it says tangent of 15 with no degree on it? That simply means you have to use a radian, yes? Which is, again, why it's so important that you let people know that you're using degrees. And sure enough, we're using degrees in these right triangles. So put these in your calculator. That's a simple linear equation. Multiply those values to x. Whatever it is, I don't have an answer for that one in the notes either, but these come out of your calculator, yes? X times whatever, point something something, x times point something something, combine like terms, yes? You can even do what? Factor out an x, add these two together, come up with an answer, divide it out of 200, and what's important is that you tell me feet at the end. Okay. And finally, the last question I had there in the notes was 50. So let's see what problem 50 has to say. What picture can we draw for it? Okay, so it says, there's an antenna on the top of a building. Okay, fine, here's a building. And here is the antenna. From a location 300 feet from the base of the building, so that's 300 feet from the base of the building, the angle of elevation to the top of the building, that's the top of the building, is measured to be 40 degrees. From the same location, the angle of elevation to the top of the antenna is measured to be 43 degrees. Okay. All right. And it kind of is blurry, even though the antenna, I'm sure it's not at the edge of it, but further back. But once you look at it from here, yes, then you kind of see it as one straight line, the antenna plus the building. Good. Find the height of the antenna. Okay. So how can we figure this part out? Maybe same as there, I should use some values. And here it is. So the thing is, that's the problem. And again, easily fixed in chapter 8 when we talk about the law of sines and cosines. H is not an angle in a right triangle, right? So I won't be able to find H with opposites over adjacents and so on, because this is not a right triangle. Yes, none of the angles are right. Okay, so again, not a right triangle. So what can I do? Well, I can go back to right triangles. So what's a right triangle? Well, this one down here, great. Now, ignore the rest. This triangle here, could I figure something out? I have an angle of 40 degrees. I have this side here is 300 with one angle, of course, other than the 90-degree angle. With one angle, one side, I can figure out the rest of it. So what would it be what would I want to figure out? I might want to figure out the height of the building, right? So I'm going to call this X, right, from here to here. Okay. Okay, do we have a second right triangle? Sure enough, I use the blue. What's my second right triangle? From here, down, all the way up, and here. And what do I know in this blue triangle? I know this angle is 43 degrees. I know this side here is still 300 feet. And what I could find is this long side, let me call it a Y, right? All the way to the top. So great. So then what will H equal to? H will equal to Y, building plus antenna, minus the X, just the building. Yes, so that's, and both X and Y I can find out of this right triangle. So let's see, how do I find Y? I have this angle of 43 degrees. I have the adjacent side 300, and Y is the opposite side. So definitely tangent of 43 degrees is equal to Y, the opposite side, over the adjacent side, which is 300, right? So opposite over adjacent. So Y is going to equal to 300 times tangent of 43 degrees. Okay, perfect, that's a number. Minus, how do I find X? I said from the smaller triangle, yes? So in the smaller triangle, this angle is 40 degrees, so tangent of 40 degrees is the opposite, so the X part, over the adjacent, which is still 300. Okay, so X is going to equal to 300 times tangent of 40 degrees. Okay. Put all this in your calculator, and you're going to come up with an answer, and that answer will definitely be in feet. Okay. So there is that. Good luck with your homework. I definitely noticed, I can't not tell you. I did notice that I forgot to tell you something really quick about in 5.3, so just so you'll be able to do the homework. We could have talked about this when we draw the graphs, but I guess the book puts it here. I'm going to put this in even versus odd functions. We haven't graphed the trig functions yet. It's actually coming up in the next section. But you've also learned these. Which of the trig functions are even? It's cosine and its reciprocal, which is secant. Which of the trig functions are odd? It's sine and tangent. And of course, their reciprocals, cosecant and cotangent. What does it mean for a function to be even? What does it mean for a function to be odd? If you remember from chapter 1, and let me draw you a picture and show you why. Cosine is even, whereas tangent is odd. If I'm looking at an angle theta, and I'm looking at its opposite, negative theta, okay? And let's say I'm on the unit triangle, I'm on the unit circle, so that r is equal to 1 and I don't have to worry about it, yes? What is cosine of theta? Cosine of theta is the x-coordinate, yes, of this point. What is cosine of the exact opposite of this angle? Well, cosine of the exact opposite of this angle is the x-coordinate of this point. Now, what could you tell me about these x-coordinates? They're both positive, yes? And of course, if my picture was pretty, you would definitely see that it also has to end at the same exact x, which means that what? Cosine of some angle theta is the same thing as cosine of its opposite angle. So that's exactly what makes a function even. A function is even if f of x is the same thing as f of negative x. Just think about the x squared function, yes? If you put in a x value or a negative x value, you get the same exact answer. So that's what makes a function even. What makes a function odd is that you get the exact opposite. So if you plug in a negative x for x, you get the opposite of what f of x would have been. So think about the cubic function. All right, so let's look at that. Same angles. And let's see why is sine odd. What's sine of theta? Well, sine of theta is the y-coordinate of this point. Yes, that's what sine is. It's the y. Great. What's sine of negative theta? Well, looking down here, is it the same y? No, because in fourth quadrant, y is negative, yes. But the thing is, it's not a different value. It's the exact, it's at the same distance, just in a negative direction. So sine of negative theta is negative y. So what did we find out? That sine of negative theta is negative, right? The opposite of y to sine of theta. So if you have, so basically this is what it says, that if you ever have a negative angle inside a cosine, and it really doesn't matter what angle you have in there. Cosine of negative 40 degrees is the same thing as cosine of positive 40 degrees. And we're going to play with things like this where we'll put a minus theta or minus x. Cosine of minus x is the same thing as cosine x, right? So it stays the same. Whereas, and again, of course, tangent is the ratio between a negative and a positive, so that's why it's still negative, so it's odd. So let's say I have a sine of negative 230 degrees. What does sine of negative 230 degrees equals to? Sine throws the minus out. So it's the opposite of sine of positive 230 degrees. Does that make sense? So cosine ignores the minus, so cosine of a negative is the same thing as cosine of the positive, whereas sine throws the minus out. Tangent of negative 2 pi over 5, I don't know, let's just put radians, is equal to what? Negative tangent of 2 pi over 5, yes? So tangent, sine, throw the minus out, right? And of course their reciprocals do the same, okay? So this was chapter 5. I know There's a lot more to it, possibly. The good news is that you've already gone through all of this trig stuff. There's really nothing new that we learn in pre-calculus. All the stuff that we are learning in pre-calculus, you have already taken in your trig classes because you had to take trig before. I'm just trying to refresh your memory. Any questions, you guys email me. I know it's a lot.